Hi guys. Today we're going to continue with solving inequalities as we have been, but we're going to look at two special cases. So we're going to take a look at what happens when it's a little bit out of the ordinary. The actual solving part will still remain the same. What will change is we're going to have some special answers and some special graphs. So let's get started. Here's our first example. Again, the actual solving part is not anything different than what we've been doing. So if you want to challenge yourself, pause the video and try this one on your own. Since this is an example, I will walk you through it. Our first step is to distribute the 2 that's on the right-hand side. Next, I like to move my variables together. So in this problem, that would mean adding 8a to both sides of the inequality. Now, in this problem, we'll have a negative 8a plus 8a on the left-hand side, and those will cancel out, leaving me with no letter a's. On the right-hand side, I have the same thing. I also have a negative 8a plus 8a, and so those are also going to cancel out, leaving me with no a's anywhere in the whole problem. And that makes this a special case. Now, in our equations, it was very easy to tell which special case it was because to get a true statement, you had to have a number equals itself, like 5 equals 5, negative 2 equals negative 2, something like that. In an inequality problem, you have to pay a little bit closer attention because to get a true statement, you don't have to have two numbers that are equal. You just need the inequality to be true. So don't assume it's always false. Actually, read the inequality out in your head and try to figure out, okay, does this work or not? In this problem, the inequality says 15 is greater than or equal to 10. And that is true. 15 is greater than 10. So this is a true statement. Now, neither of those are the actual final answer. We're not going to write the inequality with just numbers. We're not going to write the word true. For the final answer, we're going to write the phrase all real numbers. All real numbers. That means that every number that exists in the entire universe is an answer to this question. All of them. Decimals, fractions, square root of 2, every number in the whole entire world will work if I plug it into this inequality. So that's the final answer that we would write for an answer line. But all of these problems also need to be graphed. So let's try and graph this. So I have my number line. I don't need to put the actual numbers from the inequality on my number line because I'm not going to start at 10 in shade or start at 15 in shade. And so I still like to put that reference number of 0. And then if I want to show on my number line that all real numbers are answers, that means I want to color in the entire number line. So you're going to draw a number line and then you're going to shade it all in, all the way edge to edge. Every single thing is an answer. Okay, so that's how you graph an answer of all real numbers. This was special case number 1. Let's take a look at special case number 2. Again, if you want to challenge yourself, you can pause the video and solve this on your own. Since this is an example, I will solve it for you as well. The first thing that I like to do in a problem like this is I like to combine like terms. I noticed on the right-hand side that there were 3 terms, so 2 of them are like terms that I should combine together. Specifically, I will be combining together the 7m and the minus m. 7 minus 1 is 6. My preferred next step is to move my variables together. In this problem, that means subtracting 6m from both sides. Now, just like on our previous problem, I have a 6 minus 6, which makes 0 m's, so there will not be any more m's on the left side. And the same thing happens on the right side. So all of my variables have canceled out. I have no more letters in this problem, and I am left with this statement. Now, again, it's not always super obvious if it's true or false when it's an inequality. So you really need to know what each inequality is. You need to know what a greater than symbol looks like and what a less than symbol looks like. And then you got to figure out if it's true or false. So in this problem, it says -5 is greater than 7. And that is false. Negative numbers are not greater than positive numbers. Negative numbers are smaller than positive numbers. So this is a false statement. Now, again, the inequality is not your final answer. The word false is not your final answer. Our final answer is a phrase, and this phrase, since it's a false statement, is no solution. So my final answer to this question is no solution. There are no numbers that exist in the world that would work if we plugged them in to this inequality. I will always get a false statement. Now, if I ask you to graph this, you're going to draw your number line. And again, you don't need to include the numbers -5 or 7 because we're not like going to start there in shade. And I like to put the number 0 for a reference point. And then if I want to indicate that there are no solutions to this answer, that means that no numbers on the number line are answers, then that's it. I just leave an empty number line. You don't want to put any circles. You don't want to put any shading because as soon as you start drawing on the number line, you're now telling me that there is a solution to this problem. And there is not. So no circles, no shading. Just put the 0 for the reference point and then leave it empty. So an empty number line means no numbers on the number line are an answer, which is why the answer is no solution. This concludes today's video.